Hello everyone, welcome to the lesson on basic combinatorics. It's all about counting. We're going to start off with the fundamental counting principle, then move on to permutations, and then combinations. Let's start off with a definition. The fundamental counting principle says, the number of ways in which a series of successive things can occur is found by multiplying the number of ways in which each thing can occur. Let's apply that to our first example. This morning, Sea-Dog woke up and couldn't decide what to wear. He had to decide between 2 pants, 3 shirts, and 2 shoes. Help Sea-Dog find all of his outfit possibilities. Well, according to the fundamental counting principle, we can say that the number of pants he has times the number of shirts he has times the number of shoes he has will determine how many different outfit possibilities he has, which is 12. And that is true. And it's pretty nice to look at a tree diagram to see the number of possibilities. First, he has 2 pants to choose from, then 3 shirts. So at this point, we have a total of 6 outfits. And then 2 pairs of shoes, then gives him 12 different possibilities here. And you can use that tree diagram with any fundamental counting principle problem. This next example would not be a good one to draw a diagram of. There would just be too many different branches. Let's look at this one. It says that you are taking a multiple choice test that has 10 questions. Each of the questions has 4 answer choices with 1 correct answer per question. If you select one of these 4 choices for each question and leave nothing blank, in how many ways can you choose the answer? Can you answer the questions? So I have 10 different dashes representing the different questions, and in each different question we have 4 different answer choices. So the first question we have 4 different answer choices. Second question, we have 4 different answer choices. Third question, 4 different answer choices. And so if we want to figure out how many different total options we have of picking the answers on this test, we would have to multiply. And if we multiply, we have a 4 to the 10th power, which gives us 1,048,556 different ways that we can choose the answers on this test. Let's look at our next problem here. Counting principle example number 3. Telephone numbers in the United States begin with 3-digit area codes followed by 7-digit local telephone numbers. Area codes and local telephone numbers cannot begin with 0 or 1. How many different telephone numbers are possible? Okay, so we have 10 total different digits that we could choose from. And in the first spot for the area code, we can't use a 0 or a 1, which means that we're left with 8 different options there. And then the second spot for the area code, we have all 10 digits, and then the third spot as well. So if you multiply 8 times 10 times 10, you're going to get 800 different area codes that we could choose from in the United States. The telephone number cannot start off with a 0 or 1. So once again, we have an 8 there, and we have 10 different options for all the other digits within the telephone number. So we want to multiply to figure out how many total options we have for all of the telephone numbers in the United States. And we have a lot. We have over 6 billion different ways of getting a telephone number here in the States. Okay, so we're going to move on to permutation right now. And a permutation are different arrangements of a group of items where order matters. The ordering matters in the group of items. So let's think about a race where we have first place, second place, and third place. And let's say that there's 5 people in the race. And in the first position here, how many different ways can we get first place? Well, we got 5 people in the race. And then we go to the second spot. How many how many ways can we get second place? You got a total of 4 people that could get second place because we already chose first. Now for third place, we have only 3 people that could get the third place position. So we have a total of 60 different ways that we could get first, second, and third place out of a total of 5 people there. So let's address the order mattering part a second. So let's say Mr. R, he gets first place, Miss S gets second place, and Mr. K gets third place. Well, that's different. That's different. The order is different than if, Mr. K gets first, and then Miss S gets second, and Mr. R gets third. So permutation, the order matters. The way that you arrange things actually matters. Let's look at this first example here. It says that you and 19 of your friends have decided to form an internet marketing consulting firm. The group needs to choose 3 officers, a CEO, an operating manager, and a treasurer. In how many ways can those offices be filled? We have 3 different positions that need to be filled, and we have 20 different people that could fill those positions. In our first spot, we're picking the CEO, and we have 20 different people. But as soon as we pick that CEO, for the operating manager, we only have 19 people to choose from. And then the last one here, we have treasurer. We've already picked 2, so we have only 18 to choose from. So if we want to figure out the different possibilities we have, we would have to multiply. And we end up with 6,840 different ways we could choose those 3 offices with 20 different people. Let's look at the next one. We have a corporation that has 7 members on its board of directors. In how many ways can it elect a president, vice president, secretary, and treasurer? Similar to the last problem. So picking the president, 7 people have a shot. Once the president's been picked, we have 1 less person. Once the VP's been picked, we have 1 less person. Once the secretary's been picked, we have 1 less person. And we have to multiply each one of those numbers together to figure out how many different ways we can elect the board of directors, which is 840. All right, this next one, you need to arrange 7 of your favorite books on a small shelf. How many different ways can you arrange the book, assuming that the order of the books makes a difference to you? This is getting to be easy, right, guys? Multiply. All right, let's move on to the next problem here. Actually, let's start talking about combination. Combination is a different arrangement of a group of items where the order does not matter. So let's think about a race again. Let's say we have 3 different winners from a race of 5 people. And it doesn't matter who comes in first, second, or third. If Miss S comes in first and Mr. R comes in second and Mr. K comes in third, that order is no different than if Mr. R came in first, Mr. K came in second, and Miss S came in third. So a combination is just an order where the order doesn't matter, the group of items where the order doesn't matter. As long as you have the same elements within the group, these 2 orderings make no difference. So let's look at an example of a combination, and we're going to look at what a combination is by first looking at a permutation. Part A says, how many different permutations are there of ABC taken 2 letters at a time? So we have 2 different letters that we're going to pick, and we want to figure out how many different ways we can choose these 2 letters from 3 different letters. So for the first position here, we could pick A, B, or C. That means we have 3 different options there. As soon as we picked A, B, or C for the second spot, we have only 2 different letters to choose from. So if we multiply how many different options we have a total of 6. 6 different options, 6 different permutations of ABC taken 2 letters at a time. A combination states that the ordering of those letters does not matter. So what that means here is if we're looking at AB and BA, these two are no different from each other. The order doesn't matter. So AB and BA are the same thing. Now we look at AC. AC and CA are the same thing. The ordering doesn't matter. So we're going to cross off that CA. BC and CB have the same letters. The order doesn't matter. So we've eliminated all the duplicates. And how many different combinations are there of ABC taken 2 letters at a time? We have a total of 3 different combinations of ABC taken 2 letters at a time. Now, how do we get the 3 mathematically? We figure out the permutation of ABC taken 2 letters at a time. So we have 3 times 2. But then we need to divide by the number of ways in which we can arrange 2 different letters, which represents A2 times A1. So we have 3 times 2 divided by 2 times 1, which gives us 6 over 2, which is 3. A combination is literally just a permutation divided by the number of ways the set can be arranged. Let's look at this second combination example. It says that a 3-person committee is needed to study ways of improving public transportation. How many committees could be formed from 8 people on the Board of Supervisors? So we have 3 different slots to pick. So the committee members, if we choose Mr. R, Mr. K, and Miss K, that's the same as, goodness gracious, why did this screw up on me?